Hello, I'm Joe Rotarius, and I'll be the narrative today. I am presenting on the cost of the United States increasing average temperature in natural disasters and measured by insurance losses. My introduction is the concern about climate and the cost is in an area that is a hot topic for many people. I explore the cost of the climate change and focused on the United States average increase in temperatures and natural disaster events that have occurred over the last 10 years. The Insurance Information Institute tracks natural disasters and insured losses for each event every year. The National Center of Environmental Information tracks average temperatures over time. By establishing the relationship between natural disasters, temperature changes, and the associated cost with which it is insured losses, I want to attempt to show the relationship between climate change and actual costs. If the actual cost can be quantified, then I am hoping that over time it can influence how the government, legislators, and businesses can help minimize the cost through changes in policies that will help protect the environment. Hypothesis and findings. The null hypothesis is that when natural disasters increase due to temperature, insurance losses will increase. The alternative hypothesis is that when natural disasters increase due to temperature, insurance losses will not be affected. There is a positive correlation between the change in the average temperature in the United States and the natural disasters. There's a positive correlation between the cost of insured losses and the mean temperature change. Mean temperature changes in the United States can impact disasters and insurance claim costs as well as losses. Why is the topic so important to study? My literature review. Based on the Insurance Information Institute, the cost for natural disasters over the last 10 years totals $518.2 billion, which is an insanely large number. Some events that were the most costly, which include Hurricane Harvey, Hurricane Maria, and Hurricane Irma, which were all occurred in 2017 and are considered the most expensive. Obviously, the most expensive natural disasters, and that is just a very, very large number. And another article just published in September 2021 by M. Yaganmohan, the average temperature increase for 2020 was 2.34 Fahrenheit degrees. Higher and increase in temperature impacts were weather patterns, which is very, very interesting, especially going back to, obviously, over the last 10 years, something totaling to $518.2 billion. It's definitely something that would strike a very large concern or an awareness. Literature review continued. A U.S. Bureau of Economic Analysis article by William Norhaus recommends that environmental factors should be measured and counted as part of the GDP, which shows the significance of the cost, GDP being gross domestic product. The human toll from climate change and natural disasters also includes the loss of life. This is a real cost to society, but my analysis does not include this, even though it is still very, very important. Adam B. Smith's article published in January of 2021 reports that the 2010 to 2019 compared to the previous 10-year period of 2000 to 2009 had almost twice the number of large disasters costing $1 billion or more dollars. And so now that is more of a modern day issue that you can see of billions of dollars still being spent and a problem still not being minimized. All of these articles support the fact that climate change is costing a lot of money and the cost continues to rise. Let's getting more and more expensive for the more and more damage due to temperature increase over the following years. Model and variables. Variables include data from the last 10 years from the United States and include the independent variable is natural disasters. The dependent variables are average temperature and insured losses. A linear regression model was used as well. The equation has the form y equals a plus bx, where y is the dependent variable of total insured losses. X is the independent variable of natural disaster events, and also temperature increase. Data description. Data was collected from the NOAA Natural Center for Environmental Information, published in November 2021, and the Insurance Information Institute for the United States. Dates used were from 2009 to 2020. Data for the increase in temperatures year over year in Fahrenheit degrees, the number of natural disaster events occurring each year, and the insured losses total for each year were used to determine the relationships moving forward. Natural disaster events were included that cause 25 million or more in insured property losses, which is just such a significant number for just property alone and very, very expensive. Missing data. There was some data missing among the 10-year period selected to account for this. The mean of the total of available observations was used to account for the missing data. As well as this, running the code, some difficulties I ran into where with cost of insurance, I decided to, or by accident, leave dollar signs. So I was unable to actually run my regression at first and import my observations. Eventually, after spending a few hours figuring it out, obviously it was the most common thing, which was just take out the dollar signs. And here are my summary statistics. The standard deviation is negative 0.05 for insured losses, and that shows that there is a 95% confidence level that my hypothesis is a true one. As you can see, like I said earlier, the variables are natural disaster events, average temperature increase, and insured losses in dollars, millions. I've had 13 observations. The mean over mean observations, 111. 54 degrees Fahrenheit increase with a total decrease or degrees increase of 6.47. Insured losses in dollars was 32,379. Coefficients are as seen, as well as standard deviation. Robustness. If an additional dependent variable of fatalities was introduced, it would maintain the same result because insured losses would increase, since it would be additive. If the average temperature increase dependent variable was removed from the same result would apply, since natural disasters as the independent variable is a measure in an indirect way of temperature increase. For my conclusion, natural disasters show the effective of temperatures increase, which definitely causes an insured losses each year to increase. So we should expect insured losses over time to increase as natural disaster events increase as well due to the temperature increases, unless we can slow down temperature increases, which is obviously a very, very big thing here nowadays with global warming. What could be studied in the future? Number of fatalities and associated costs due to natural disasters, overall economic costs due to natural disasters, and how the cost of natural disasters or climate change could be a factor with gross domestic product. And those are just a few other ways that could be very interesting moving forward in the future. Thank you for your time, and I hope you have a wonderful break.